Let's go back to the dynamic array. So are there alternatives to doubling the array size? Right? We doubled each time. What happens if we didn't double? Well, we could use some different growth factor. So for instance, we could use 2.5. So grow the array by more than 2, or grow the array by less than 2. As long as we use some constant multiplicative factor, we'd be fine. The question is, can we use a constant amount? Can we add by a particular amount, like let's say 10 each time? And the answer is really no. And the reason is, as the array got bigger and bigger, and we have to resize every 10 times, we just don't have enough time to accumulate work in order to actually do the movement. Let's look at it another way. So let's look at an aggregate method. Let's say C sub I is the cost of the ith insertion. Okay? We're going to define that as 1 for putting in the ith element, plus either I minus 1 if the I minus 1th insertion makes the dynamic array full. So that is if I minus 1 is a multiple of 10 and it's 0 otherwise. By the definition of our aggregate method, we're just the sum of the total costs divided by n. And that's n plus, again, that's the 1 summed n times is just n, plus the summation from 1 to n minus 1 over 10 of 10j. That is just the multiples of 10 all the way up to, but not including n. So 10, 20, 30, 40, and so on. All that divided by n. Well, we can pull the 10 out of that summation. So it's just 10 times the summation j equals 1 to n minus 1 over 10 of j. So that's just numbers 1, 2, 3, 4, so on, all the way up to n minus 1 over 10. That is order n squared, that summation. So we've got n plus 10 times the order of n squared over n, which is just order of n squared over n, which is order n. So this shows that if we use a constant amount to grow the dynamic array each time, that we end up with an amortized cost for pushback of order n rather than order 1. So it's extremely important to use a constant factor. So in summary, we can calculate the amortized cost in the context of a sequence of operations. Rather than looking at a single operation in its worst case, we look at a totality of a sequence of operations. We have 3 ways to do the analysis: the aggregate method, where we just do the brute force sum based on the definition of the amortized cost. We can use the banker's method, where we actually use tokens and we're saving them conceptually in the data structure, or the physicist method, where we define a potential function and look at the change in that potential. Nothing changes in the code. We're only doing runtime analysis. So the code doesn't actually store any tokens at all. It's an important thing to remember. That is dynamic arrays and amortized analysis.